Bienvenidos, Ushamdeed, and welcome to another NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're going to be taking a look at Lab 3.1.1.13, where we're going to be working with the Gregorian calendar and taking a look at the essentials of the if, elif, else statements. Now, let's go ahead and dive right in here and see what the lab is requiring us to do. As you can see, it should take 10 to 15 minutes. Level of difficulty is easy to medium, and we're going to be utilizing if, elif, else statements. But here's the scenario that we're working with. The Gregorian calendar, which was created in 1582, or I should say we converted to the Gregorian calendar in 1582, we can determine whether or not years are leap years or common years based off some certain equations. Now, when I first pulled this up, I had to go back and take a look at Wikipedia to get their definition to see a little bit more about the Gregorian calendar. And we're going to come back and take a look at this statement as well, because we're going to look at this problem from the perspective of the lab, and I'm going to give you the lab solution up front. We're going to see that. It's very straightforward. And then I'm going to come back and we're actually going to look at using a logical AND in order to address this problem based off the description that's given here, is that every year that is exactly divisible by 4 years is a leap year, except for years that are exactly divisible by 100. But those centurial years, which are years that are exactly divisible by 100, are leap years if they're exactly divisible by 100 and exactly divisible by 400. And again, divisible by 4, divisible by 100, and divisible by 400 makes that, we'll call it a centurial leap year. And so I'm going to give you some examples, or an example of how you could address that using the logical AND. So let's dive back in to Lab 3.1.13 here, and you can see that we're prompting the user for input. Now I'm going to do this all in the Python Integrated Development Learning Environment, idle, and we've also got the interactive interpreter up there that we can use to take a look at some of these things to see what the results will be if we were to isolate some of the operations we're going to be working with. Now, if we come down a little further, the code should output one of two possible messages. It's either going to say that it is a leap year, or it's going to say that it's a common year. Now, remember, we're prompting the user for input up here on the first line. And what we're going to be doing, again, as a reminder, it's called explicit type conversion, or you'll hear me refer to it a lot as typecasting. Those are synonymous terms. Again, explicit type conversion and typecasting, those are synonymous terms. But what does it mean? So remember, explicit type conversion is when the user uses a function to convert an object from one data type to another. And that's what we're doing up here. Remember, we're prompting the user for input. Now, the input function by default is returning a string. However, if we have them enter a year and we want to use the modulo operator, in other words, we're trying to do some division type work to see if we've got a remainder or if there's no remainder, we can't do that on strings. We would want to do that using an integer. And so that's what we're doing here. Explicit type conversion, because I'm explicitly converting the data type from the default of a string with the input function here to an integer so that I can then do some mathematical operations on that input. All right, so let's go ahead and jump over to the Integrated Development Learning Environment. You can see I've got a couple comments here. I've already saved this off so we don't have to go through me typing a file name in. And let's go ahead and dive right in here, and let's just go ahead and say year. And remember, this is typecasting right here. And we're going to use the input function to prompt the user. And I'm going to say, please enter the year, just like that. However, that input statement that's there, the function, and I say statement because it's the input and then the open parents, please enter the year. We've got that statement in there. I enclose all of that into the int function, so I convert whatever is typed in into an integer. Now, the first thing that activity, this lab is asking me to check is to see, remember, we're talking about the Gregorian calendar, 1582. And so if we get a year before 1582, we want a message that simply says, not within the Gregorian calendar period. Well, this is the start of our if, elif, else. And the first thing we're going to check is to see if the year is less than 1582. We're simply going to go ahead and print out a message that says, and what does that message say again? Not within the Gregorian calendar period, I think. Yep, there we go. And again, that's the first thing that we want to check for. And the reason we check for that first with the if statement is we don't want to go through doing a whole bunch of comparisons if we haven't first checked to see, is that year, does it even qualify for me to determine if that's going to be a leap year or not? And so again, so if the year is less than 1582, so if it's 1582 or greater, it is in the Gregorian calendar. And now we get into our first elif. And what are we going to be checking for here? Well, if we were to take a step back and come right back up here. So it says if the year number is not divisible by 4, right? It's a common year. And if I was to come over here, remember, it says every year that is exactly divisible by 4 is a leap year. The lab is just wording it differently. They're just saying if it's not evenly divisible by 4, it's a common year. In other words, it's not a leap year. Now, they're kind of walking us into a solution, right? And you can see here we've got the not equal to and the modulo operator. So here's really what they're looking for, because if we're saying that every year that is exactly divisible by 4 is a leap year, then the opposite is true. If it's not exactly divisible by 4, then it's not a leap year. It's a common year. And again, if it's not exactly divisible by 4, if there's a remainder, in other words, if it's not equal the division, or I should say the modulo operation, if it doesn't return a remainder, in other words, if what we get back is a 0, then that tells me it is evenly divided, And so let me give you an example of that here in the interactive interpreter. So if I was to say, and we'll use some years. So we'll say 1996, modulo of 4. And as you can see, we get a remainder of 0, which means that is evenly divided by 4. Now, if I was to check to see 1999, modulo 4, you can see that we end up with a remainder. So that would not qualify as a leap year. And again, we can eliminate all non-leap years by simply saying, let's come back up here. Let's get the cursor up there. So if the year modulo 4 is not equal to 0, right? So if it's anything other than 0, that tells me what? That tells me that this, we'll do capital C there, that this is a common year. So again, elif, the year modulo 4, so whatever the value was that was entered in for year, and I do a modulo 4 to divide it by 4 to see, do I have a remainder or not? If it is not equal to 0, in other words, if it's 1, if it's 2, if it's 3, that tells me right there it's not evenly divisible by 4. So it is a common year, period, end of story, right? So that's the first elif statement. Now, let's go ahead and take a look at what is going to be the next elif statement. So we've just handled that right there, right? And that's probably the first thing after checking to see if the number is less than 1582. The next thing we're going to check or test is it evenly divisible by 4, right? Because if it isn't, it's a common year. And that, again, then you're done. Now let's come here. Otherwise, and here's an elif. You can think of otherwise, and the reason they say if here to start, they just didn't use otherwise here because in the flow of the text, they don't have you checking in the flow of the text here. It doesn't say check to see if it's greater than or equal to 1582. It starts in with the conditions they want you to check. They talk about the 1582 down here, and that's why here it says if and then otherwise, otherwise, otherwise. So otherwise, again, when you see otherwise, think elif. So if the year number isn't divisible by 100, it's a leap year. And so that's going to look very similar to the previous statement we had. Because remember, right here, we just eliminated all possibilities where the year entered is not evenly divisible by 4. And those are all of the common year scenarios that we have. And so then let's go ahead and say elif, and what are we going to do here? So year modulo 100, because again, what is it asking for? If the year number is not divisible by 100, evenly divisible by 100, and that's going to be not equal 0. Let me make sure I've got that right. So elif year modulo 100 not equal to 0, we are going to print leap year. Right? Because again, we're checking here. The first thing we check, is it greater than 1582? Right? So, and let's say that yes, that's the case. The next thing we check is the year modulo 4 not equal to 0? Meaning, do we have a remainder of some kind? If we do, it's a common year. But what if it is evenly divided by 0? Then we check to see, so we know it's divisible by 0. Now we're checking to see, is that year value evenly divisible by 100? And I should say, is it not evenly divisible? If it's not evenly divisible, but it is divisible by 4, but not by 100, we have a leap year. And so let's go back over here and you can see the exception. Every year that is exactly divisible by 4 years, right? So that the first elif would fail, we would come down to the next elif, except, oops, sorry, I wanted to highlight, except for years that are exactly divisible by 100. But these centurial years are leap years if they are exactly divisible by 400. So here we're checking to see elif the year value modulo 100, is it not, we're testing, is this true or false? It's true if we get a remainder back, right? And then we would say it's a leap year because it's divisible by 4. We know that because that test failed. But is it not divisible evenly by 100? We get a leap year. And then the final one was the 400, right? And that's sort of, they're dealing with year modulo, what am I saying here? 400 not equal to 0. And we're going to print in, what are we checking for over here with the 400? Otherwise, if the year number is not evenly divisible by 400, it's a common year. And so then we'll just print down in here, common year. And actually, I'm going to change this a little bit. I'm going to say common year, and I'll say not divisible by 400. That way we can get some, we'll see something a little bit different here. That way we can identify which conditional statement we're hitting when we're in the code. And then they have sort of the else here. And then otherwise, it's a leap year. And so that's kind of my closeout else statement. And we'll just say else. And then we'll print, and I think they said leap year. This is the else leap year statement. Right, so we'll get this code in here. All right, so if I hit F5 and I hit OK, let's go ahead and let's run through the values they want us to enter in here. And so let's see what we've got there, 2000, 2015. So we'll start with 2000, right? And we see that this is the else leap year statement. So this was not true. That was not true because, again, it was equal to 0. 2000 divided by, or I should say, 2000 divided by 4 is going to be equal to 0. And if it's divided by 100, it's going to be equal to 0. If it's divided by 400, it's going to be equal to 0. And we're checking to see, is it not equal to 0? And so then we get the else leap year statement. And again, it would have said leap year. Let's check 2015. Let's go ahead and run this again with F5. And then we'll come over here and type in 2015, and we see it's a common year. And we know it's a common year, and we know that it's hitting that right there. Because that, again, that first statement is critical, because that is going to weed out any non-leap years, right? That would be, that again, the conditional modulo 400 statement, but this literally weeds everything out, right? If I can't divide it by 4 evenly, it's period. It's a common year. Done. Again, we've got this exception that we're dealing with over here, but initially, if I can't evenly divide by 4, it's game over. It cannot be a leap year, so we know it's a common year, and 2015 met that requirement. Let's hit F5 again, and what were we, 1999? And again, common year. 1,999 is going to be, this is going to test true, right? Modulo 4 with the year not equal to 0. Boom, we got a match, right? So it's a common year. Let's hit F5 again. And let's go with, I think it was 1996. And we see 96 as a leap year because 96 is evenly divisible by 4, right? And so we don't see common year. That test fails. And then it's checking to see 96 divided by 100. Is it evenly divided by 100? Is it not equal to 0? And the answer is yes, there's going to be a remainder there. In fact, if I was to say 1996 modulo 100, that is not equal to 0, right? And so that is why it was evenly divisible by 4, but it's not evenly divisible by 100, right? That's that not equal to 0. That's what we're looking at there. So we see leap year printed out. And then the final date, I think, was, actually, have we just 96, 1580, right? So we want to check to see, well, what happens if I was to type in here the 1300s, right? That's not within the Gregorian calendar period because it is less than 1582. What if I type in 1582? We get a common year, right? So it was not a, I'm sorry. What am I trying to say here? Sorry, I'm getting tongue-tied here. So we did the division. It is not equal to, it's not evenly divisible by 4. So we end up with a common year, right? And so that's the output we receive right there. All right, so now let's go ahead. Let's take a look at this Gregorian calendar here, and let's look at this in a different way. You'll notice it says that every year that is exactly divisible by 4 is a leap year, right? And so we were checking the reverse of that. We were, again, I shouldn't say the reverse so much, but we were checking to see if it was not divisible by 4. That was the first thing we were looking at. So let's look at this. And again, that's the solution, right? So here's the solution to the lab. Now we're going to tackle this in another approach. And we're going to leave that there because we still want to check that right out of the gate. And actually, let me do Control Z and let's pull this back. The first thing we're going to check for is if it's not divisible by 4, because we know that if it's not divisible evenly by 4, it's a common year. That's it. Discussion is over with. So now let's come down and let's go ahead and say elif, and here's what we want to check. Let me think about this for a second. So if I was to say elif year, and we're going to check for the first statement out of Wikipedia, right? So if I forgot the modulo 4. There we go. So if year modulo 4 is equal to 0, and here's where we're going to leverage the logical and. So I'm going to see if the year is evenly divisible by 4 and is the year modulo 100. And if you would look over here, remember, so every year that's exactly divisible by 4 is a leap year. So again, here I check for non-leap years. I'm checking for common years here. But here I'm checking to see, is it divisible by 4? And is the year evenly divisible by 4? And if I say divisible, I'm talking about evenly divisible. And is the year evenly divisible by 100? Because here it says, except for years that are exactly divisible by 100. But those centurial years are leap years if they're also exactly divisible by 400. So let's go ahead and say, and the year is exactly evenly divisible by 400. And that is what that statement says. So this kind of looks at it not from the negative perspective, right, with the not equal to. We're saying if the year is evenly divisible by 4, and the year is evenly divisible by 100, and the year is evenly divisible by 400, that is also, and here's what we'll say, whoops, we're going to call this something special. I'm going to say, this is a centurial leap year, right? Because that is what they just described to us here. Every year that is exactly divisible by 4 is a leap year, except for the years that are exactly divisible by 100, but the centurial years, which are the years divisible by 100, are leap years when they're divisible by 4 and divisible by 100 and exactly divisible by 400. That is our statement there to catch us. Again, this is going to come up in 3132, I believe is where that chapter is going to be located. And so we can test that. You can see right here. So 17, 18, and 1900, it should say that those are not leap years. But 1600 and 2000, those do meet this criteria. They're exactly divisible by 4 and exactly divisible by 100 and exactly divisible by 400. So 2400 is probably going to be a leap year as well, but 1700, 1800, and 1900 are not. Now, the last thing that we need to sort out here is we're going to have one more condition, because remember, elif, so if the year is evenly divisible by 4, equal to 0, and the year is evenly or exactly divisible by 100, but what if it's not equally divisible and the year modulo 400, right? Here's where we're going to check to see if it's not equal to 0. So what we're saying here is it is divisible by 4 and it's divisible by, evenly divisible by 100, but not by 400. That's kind of the example for 1700, 1800, and 1900, right? So those would be centurial years, but not leap years, right? Because remember that last condition, the centurial years are leap years if they are divisible by 400, right? If they're divisible by 4 and 100 and 400, centurial leap year. But if it's only divisible by 4 and divisible by 100, we're just going to call that a centurial year. So let's put a colon there, and we're going to say print, this is a regular centurial year, but not a leap year. How about that? All right. Now, we could also drop in an else here, right? So we've already checked up here for the common years. We've checked for whether or not it's a centurial leap year. And again, we're using this logical and here, checking multiple to see if multiple things are true, right? So again, that would have to be true, and that would have to be true, and that would have to be true for it to be a centurial leap year. And the same is true as here. The year would have to be divisible by 4, and the year would have to be divisible, evenly divisible by 100, but not evenly divisible by 400 to be a centurial year. Not just like we're saying it's, again, it's not a leap year, right? But it's not a common leap year either. It's a centurial year. And again, evenly divided by 4 and 100, but not by 400. And then we could do an else statement similar to the one that we had before, where we could simply just come out and say else print this is a leap year, right? All right, so let's test this out and see what it looks like. Let's go F5. Let me click OK. And let's run through, first let's run through the Wikipedia years that they gave us. So 1700, Wikipedia says that 17, 18, and 19 are not leap years. Let's check and see what it says. This is a regular centurial year, but not a leap year, right? Because it is divisible evenly by 100, but not by 400. Let's run this again, F5, and let's type in 1800. We should see the same thing. Let's type in F5 again here, and let's type in 1900. And again, it looks like our code is doing what we expect. Let's hit F5, and let's type in the 1600. Right? That is a centurial leap year. It's divisible by 4 and by 100 and by 400. Now, we might be thinking, well, maybe we can drop the divisible by 4 out. But again, I was just kind of following the logic there that they had on the page. Let's put this in here and let's go with 2000. And that is a centurial leap year. And let's put in 2400. That is a centurial leap year. Let's take a look at a few of the examples from the lab. 2000, that's a centurial leap year. If I hit F5, we would do 2015. That's just a common year, not divisible by 4. F5, let's do 1999. We should see that that is a common year still. F5. Let's take a look at 1996. That is divisible by 4. And so you may have been wondering, okay, well, is that going to catch anything? And it did right there, because here we're checking to see, is it not evenly divisible by 4? And then does it meet all 3 of those conditions and all 3 of those conditions? But these 2 statements here, these sort of logical and statements, aren't going to get 1996. It's going to be the else statement that captures that. Because remember, the else statement saying that this is a leap year, that's going to work because the first thing we check here is we basically identify all non-leap years are going to get caught up right in here, with the exception of our centurial year that is not a leap year. And so let's hit F5 again. And let's take a look at, what did I say? And I guess we could just go, let's say, what about 1323, right? Not within the Gregorian period. All right, well, we took a look at a number of ways that we could address this individual problem that we were working on here in lab 3.1.1.13. We looked at the if, elif, else control flow structure in Python, but more importantly, we saw that we could attack it using the logic that the lab kind of imposed upon us with the not equal to in the modulo. And then we took a look at how we look at the Wikipedia page to see, well, there are some exceptions in there. And we learned this new term centurial year that's part of the Gregorian calendar. And we saw how we might attack it from a different perspective. Again, you'll see that in 3.1.3.2 with the logical and. All right, well, that is going to wrap up this supplemental tutorial on lab 3.1.1.13. I hope you enjoyed it. Look forward to your feedback, and that's all I've got. Best of luck to you out there. Thanks for watching, and I hope to see you in the next video.